So I have known about CESMII for a while. For those that know me, I've been doing some research into reshoring for a while, just trying to understand the state of manufacturing. And I came across this public-private institute that is primarily funded by Department of Defense, Department of Energy, and I think there's other groups as well. But it's public-private, and it's under the umbrella of Manufacturing USA. And there's, I think, 14 or 15 institutes. There's like a few of them, all focused on manufacturing, R&D, and the workforce development. There's robotics. I think there was one on biosensors. And CESMII represents smart manufacturing. And so I'm very excited about this because I've been wanting to learn, other than just reading the website, about what CESMII is all about. One of the other pieces that the institutes do is also fund research. So if you're a startup and you're thinking about doing something where a grant from one of the institutes would help you, this would be one path. With that, maybe Jonathan, we can start with introduction. Where'd you grow up? Where'd you go to school? Where do you live now? You're not in Seattle. And then whenever you're ready, we can get going with the. I'll stop sharing my slide and you can share yours. So.
Sounds good. Well, thanks so much for having me here. Hopefully you can hear me okay. I'm on the HD setting, but I'll switch to SD if it ends up being a problem. Thank you for the introduction and the privilege of being here. I'm Jonathan Wise. I'm our VP of Technology. It's a pretty small organization, so don't let the title fool you. I was just the first tech hire to pad out a pretty deep team that has different expertise from across the industry. It's a deep team, but it's a small team. So we think we got some pretty influential players here who know almost every part of the U.S. manufacturing industry from one degree or another. And our biz dev guy likes to say we've got the road rash to prove it. I grew up mostly in Ontario, Canada. Our little tech hub in Ontario is the Kitchener-Waterloo area. I grew up a little bit internationally, though. My parents moved around a lot, so sticking to home wasn't really in my genes. I did live in Seattle for about 3 years while I worked for Amazon. Lived in New York for 3 years, where 2 of my kids were born, working for General Electric. Most of my career has been in manufacturing technology, and most of it has been focused on kind of the information analysis side of it. So I spent 10 years as a software developer in a couple different organizations. GE was one of them. Rockwell Automation was one of them, and joined a startup early in my career in London, Ontario called Active Plant. And although that was over 20 years ago, I'm proud to say that my software is still running in some US factories. So kind of a neat way to grow up in this space. I went to a technical college called Conestoga College. It was a business program in software development, and just ended up with my first job being trying to do software development in sort of OT technology with Rockwell Automation, and realizing from a very young age there was a disconnect there. There was a whole range of interesting technology that I hadn't been exposed to during my formal schooling, and lots of the things I thought I knew didn't directly apply in manufacturing. So it definitely was a growing up experience. After doing that for about 10 years, I transitioned more to business and product management. My kind of first transition role was with Microsoft as a technology evangelist. So I left GE Intelligent Platforms, where we were struggling to adopt some new Microsoft technology, and took this role where I was calling on GE Intelligent Platforms and other manufacturing ISVs, trying to help them get up to speed on this brand new technology that now we're all very familiar with, that we call the cloud. Microsoft chose to call it Azure, and the big debate at the time was how exactly you pronounce that. So that was an interesting couple years. Amazon was also an interesting couple years. That was my first foray into consumer technology. I was on the digital devices team, and so helped launch a number of their products, some of which succeeded and are listening to me talk right now, and others didn't succeed. I don't know if anybody remembers the Fire phone, but that was an interesting journey. And I think I learned a lot there too. So when I got the call back into the manufacturing space to work for Rockwell, it was again with the idea that I could take some of the things I'd learned from consumer technology and figure out how to fit them into operational technology. So I had a fun 4 years at Rockwell, launching a couple new product initiatives in the IoT space before joining CESMII to figure out how we put together a technology strategy. So maybe I'll share some slides and transition to talking about CESMII.
Yeah.
I'll share a screen too. Can you see it? Because I can't see that I can see it.
Yes. Yep.
All right. I will trust that you can see it.
Yes. We can see it.
As Han said, CESMII is a unique organization. We are a public-private partnership, and I'll get into exactly what that means. And we're a part of Manufacturing USA. Manufacturing USA is if you follow the politics, it's bipartisan. Everybody sort of agrees that the U.S. needs to step up into more of a leadership role in manufacturing technology, that maybe we'd fallen behind in some areas. And so a variety of federal organizations participate to fund these institutes, and they're spread across the country. And they all have a slightly different mandate. There's a new one that's starting up right now for obvious reasons around cybersecurity, where maybe we need to pay a little more attention. CESMII's acronym stands for Clean Energy Smart Manufacturing Innovation Institute. And so you can see why we go by the short name, or just the Smart Manufacturing Institute for short. So each of the institutes has a set lifespan and a set kind of purse or wallet to spend. We're about halfway through that lifespan. Some of these other organizations are in different stages of their life cycle. But while each of us have a focus, we all also try to work and coordinate together to make sure that we're investing wisely and accelerating innovation in the right areas. CESMII's particular focus is clean energy and smart manufacturing. And the public-private partnership means that the $70 million in funding that we get from the federal government is expected to be matched by private organizations that want to participate in this. So we are under the Department of Energy, and it's not the Department of Energy's intent to become an angel investor or a venture capitalist or anything like that. We don't want to create something out of the Department of Energy. Rather, what we want to do is pour fuel on the innovation that's already happening, so that if you're working on an exciting idea, but you need some acceleration, there's the potential for us to engage there. And so a significant part of the Institute is focused on choosing the right projects, creating the right opportunities for funding, going through a formal selection process so that we can say to the Department of Energy, and the Department of Energy can say to Congress that we are strategically investing. This is some of the best of what's brewing inside of this country, and this is why we're accelerating it. That's not my side of the Institute. We have a couple different legs of the stool. So I'll talk the most about mine, but I don't want to leave this slide without kind of highlighting the point that we are not here to create a product. We are not a vendor. We don't have anything to sell. Rather, we're here to invest in American innovation and see new products and new ideas come to life. We engage through a membership model. So I think in an ideal world, the membership keeps us operational, and the funding leaves CESMII and goes to other organizations to accelerate their efforts. We've given more shape to kind of those project definitions, the kinds of things that we want to invest in, and I'll talk a bit about that. But that is just one of the legs of the stool. So we call that innovation on this slide. Knowledge is another one. So we have part of our team that is focused on workforce development, whether that's working with educational organizations to ensure they have the right curriculum for the next generation, or it's empowering the existing workforce to the extent that there is interest in developing additional skills within the workforce. We want to have the right resources for them. So if there's an OT organization that needs to develop IT skills, can we help bridge that gap? And vice versa, if it's an IT organization that needs to get out of their silo and learn more about OT technology, we want to have resources there as well. And then the technology side is where I sit, and I'll talk the most about that. But from a technology perspective, we are choosing some horses. We're not completely agnostic. We observe and create theories on some best practices, patterns that we think are sustainable, and technology or standards that we want our membership to engage with. And so we advocate for those, we explore those, and we fund projects that kind of test out those theories and then recommend them to our membership based on kind of our findings. So in a sense, we're de-risking an exploration of new and emerging technologies for our members by investing in that ourselves, rather than having everyone take on pilots and do their own learnings. There's a key word in this slide, democratization, which is maybe an odd fit for the sentence that it's in. But there's a reason that we chose that word. I've worked for some of the big vendors in this space, and to a fault and with good reason, most new offerings and most kind of sales and marketing engagement teams go after the big companies. There's the most kind of return on investment for a new product initiative if you can sell it to one of the large manufacturers, where you have a chance of them, standardizing it and deploying it across their enterprise. So it makes sense to build technology and message technology in that fashion, because that's how it can pay for itself. But that isn't democratizing the technology, because if it's scaled for and priced for only the largest manufacturers, it isn't reachable for the small and medium manufacturers who could benefit from the technology, but haven't got the capital to do an exploratory IoT project to see if it might improve their efficiency, or even deploy the infrastructure that is a prerequisite for the technology project that might improve their efficiency. So when we say democratize, we mean that it needs to be accessible to all US manufacturers. This is the breakdown of small to large in various verticals within US manufacturing. And you can see that it's different for each vertical. Biofuels is primarily large and small. Forest products and medical devices, chemicals are significantly driven by small manufacturers. And it's not necessarily that the small manufacturer is the one that you see in the news, but they may be part of the supply chain for these bigger companies that limits the innovation of those bigger companies' supply chain. So if we can build and select and invest in technology that is accessible to everyone from the small manufacturer to the big manufacturer, and then back down to that big manufacturer's supply chain that is probably made up of small and medium manufacturers, then we can actually begin to move the needle. And this is my slide. I will spend more time on the tech slides just because that's where I live. But I've seen this pattern a number of times in my career and in the projects that I've been involved in. And so I might not do the slide justice, but it's worth me giving a try. The bar chart there at the top kind of describes why technology is not accessible to the small and medium manufacturers. It's not that the IoT point solution or the clever new analytic or the new visualization that helps you make better decisions. It's not that part is out of reach. You can do cool things with a Raspberry Pi and some Python. What's out of reach is deploying at scale. And that's out of reach for a variety of reasons, all of which CESMII are aiming at. It could be that the small to medium manufacturing organization doesn't have the skill set to build and deploy a solution. Or if they could find an inexpensive solution on the market, they don't have the skill set to implement and maintain that, even if it's on low-cost hardware. Yeah. Small manufacturers don't have an IT department. They may not even have somebody that's comfortable with IT technology. Some of our projects are light automation, heavy on physical work. And so without equipping that workforce for adoption of new technology, it doesn't matter how great it is. It doesn't matter how low cost it is to do the pilot project. It's out of reach. That's actually the optimistic side. The more realistic side is that the IoT offerings or the IIoT offerings, the analytics offerings, the products in our space coming from the large ISVs that are calling on manufacturers are significantly solution-based sales. And what I mean by that is they, being one of the companies that I might have worked for in the past, they have a product or a suite of products or a toolbox of components that can be stitched together to solve almost any manufacturing problem. But out of the box, they don't do anything. And sometimes it's deliberate, and sometimes it's just kind of the evolution and the necessary changes those organizations have to make to embrace new technology. They're, to a fault, sold with a system integration project. And I have nothing against system integrators. The point is that system integrators are frequently performing repetitive, low-value work in order to deploy the portion of the solution that is value creation. So our goal in accelerating technology investment, in maybe picking a few sides and being a little opinionated on which standards or best practices to advocate for, is to see the repeatability go up and the manual work to recreate a significant portion of a solution every time it's deployed go away. We don't want any participant in the industry to go away. We want all the participants to work smarter. So this is really the end goal, is whether you're a small manufacturer who needs equipping or a big manufacturer who just needs more repeatable solutions, we want to direct our federal war chest at solving those problems. So these are kind of the 5, I guess, categories of projects that we direct those funds in to hopefully help solve some of those problems. And just real briefly on each of them, because only one of them is kind of my day-to-day. Enabling R&D projects tend to be larger, kind of up to a year, fairly significant financial investment from both the federal share and the expectation from the participants, focused on new research and new development. So in some cases, this is new sensors. In some cases, this is new approaches to predictive modeling. Often these projects involve academia and an industry partner. These ones tend to attract the PhD or PhD candidates that are after a novel problem, and we absolutely invest in these. The time horizon for kind of a return on investment is longer. Everyone wants to publish or perish in that space, and so hopefully that output is worthwhile. But we also understand for this kind of project that the initial R&D doesn't immediately lead to a new product on the market. It moves the state-of-the-art forward and eventually leads to new products on the market. But sometimes there's a follow-up project required to go from kind of research to productization. Innovation projects are designed to be kind of the other side of that coin. If we can harvest or find existing output, whether it's on GitHub or the academic paper that is now ready to be turned into a real-world solution, these are designed to be tactical, short life, short investment, where there must be a manufacturer involved. That manufacturer must have a constraint that we're trying to solve, and there must be an entrepreneur or an ISV or a system integrator willing to try to put the two together, to take the innovation and apply it to the manufacturer's problem in the real world as a team, and in a relatively short window, see that idea come to life or fail fast. Because we're not a venture capitalist, the project doesn't have to succeed to be a success. The project has to test out the theory and identify whether this is something that we should pour the fuel on or take the learnings and try something different. So that's the innovation project category. I'll skip the one in the bottom right just for a second. Application projects are typically involve the established ISVs. So these may be a little bit less entrepreneurial, but there is a manufacturer, there is a software solution, and in order for the manufacturer to be able to adopt a known solution, there is some acceleration or assistance needed, or maybe there is a mix of, well, this is easy to deploy, but we're going to have to do something new in this particular scenario. So it's the application of the technology. And so that's a category of project as well. And then the final category would be the workforce development, where we're typically investing in curriculum development or resource development for educators that want to interact with the smart manufacturing space. Platform capability projects are where I live, and I'll spend the rest of my time, and either until I run out of breath or Hans waves at me and tells me to shut up, talking about these kinds of projects and why we're doing them. Throughout kind of my career, the products and developments that I've been involved with, and then the deployments of those, I've observed three problems that we are trying to address within this corner of the problem space that we're after. The first I like to call interface anarchy. We've more or less settled on the physical interface. It may not literally be an Ethernet cable, and it may not literally look like that, but we're more or less using Ethernet derived technology. There are some kinds of devices that don't, but by the time you get to the bridge between level 1 and level 2 in the Purdue model, the physical interface is fairly reliably standardized. What's not standardized is the communication coming over that wire. And this is a small selection. There was a gentleman who spoke at one of these a couple weeks ago about how the Linux Foundation is dealing with this. I think most of us acknowledge that this is anarchy. There's a funny XKCD cartoon about how standards proliferate. And each of these is trying to solve a different problem, is focused on a different space. But at this point in kind of the information software value chain, it is fairly commoditized. There are unique characteristics of each of them, for sure. There are things to consider about each of them, for sure. But more or less, we just want to get the data moving. And the first problem we hit is that even within an enterprise, there are different protocols present. If we address the nation as a whole, all of them are present. And as we, CESMII in the US, engage with industry efforts globally, even more of them are present. I put a little star on the OPC Foundation because they made an admirable effort in the 90s to unify all of this around a technology called OPC, retroactively named OPC-DA, that was a common denominator. Almost everything could be adapted to OPC with a driver. And the major problem with OPC became that it was dependent on an older Windows technology that Microsoft is still trying to kill off. The OPC Foundation rethought all of that in the early 2000s with OPC UA, unified architecture. And we could get into a long debate on the merits of UA for lots of different purposes. But the reality is UA is a broad scope specification that solves a number of problems, potentially one of which being interface anarchy or the protocol problem. So maybe I'll talk more about that later if I still have the time. Problem number 2, I call the alternate evolution problem. And so this is the thing that I first hit when I was fresh out of college and then re-hit when I left consumer technology and returned to manufacturing technology. IT and OT evolved in different ways. And so as a young, enthusiastic developer, I was shocked that there was no object-oriented programming in the OT layer, and there is, but I'll get to that in a second. The reality is that information technology evolved through the 80s and 90s to embrace OOP and then move beyond. Manufacturing technology, or what we call the OT technology, evolved from engineering diagrams and beyond, absolutely. And so we're starting to see some of the object-oriented principles kind of make their way in, but the core of the technology, the genesis of the technology on the two sides of this OT and IT divide are very different. And there's sort of an impedance mismatch that we've addressed to date by imposing an after-the-fact object model. To a fault, information software in our space requires the implementer, whether it's the end customer or a system integrator, to remodel what's happening in the control program, to remodel the physical layout of the manufacturing system into something that you can write software against. So whether that's Rockwell's Vantage Point or PTC's ThingWorks or an OSI asset framework, all of them are accomplishing the same goal, is to build a strongly typed model to which manufacturing data is bound. Now, you can take shortcuts on it, and we do, particularly when we talk IoT, but we will inevitably hit the problem of unmodeled or apparently unmodeled data that has to be coerced into some sort of structure in order for us to point a machine learning algorithm at it or build new visualization or new analytic. So that's problem number two. And I'm not saying that any of these are insurmountable, but I am saying that these are all the realities that we deal with when we build information software in our space. Problem number three is self-inflicted. So problems number 1 and 2 are the result of how our technology evolved. We didn't know 20 years ago what we know now, and we evolved tactically to solve problems and sell products to manufacturers, and we just sort of arrived at this mess. Problem number 3 is one that we are in the midst of creating for ourselves. And it's because of the same impedance mismatch, but maybe happening at a higher level. The apparent wizardry of machine learning in analyzing business data to make better forecasts or sell better advertisements seems like it should be directly applicable to manufacturing data. It seems like if we just move all of this data from the PLCs into a data lake, a smart machine learning algorithm is going to make sense of it and tell us how to become more efficient or how to use energy better. But that's a false theory. No one's been able to prove that theory, and it's because the PLC's kind of rudimentary structure is a key value pair. So if I have a PLC program running, or if I bypass the PLC program, which I've done in the past, and I just talk to the devices, what I end up with, and then if I move all of this data to the data lake, what I end up with is a data lake full of temperature samples. And temperature is a very interesting thing to analyze. Temperature going too high or trending too high could mean something really bad, or it could mean something totally normal. So if I don't construct or reconstruct the context in which that temperature value is generated, it's just noise. It's a lot of noise coming from a lot of places, all sharing the same label. This is a problem that we have to get ahead of. We cannot just connect our IoT devices and send topics and values into a data lake. It might work with one IoT device. It does not work across an enterprise where all of the samples have the same label and none of the samples have context about what equipment generated that value, what that equipment was doing at the time, what that equipment was supposed to be doing, what was being made on that equipment, who was running that equipment, and what the ambient values were for the readings around the equipment. We have to have model data. And if we don't, we have a mess, and we'll have just kicked the can down the road to a place where it's even harder to solve. So our exploration on solving these three problems is something we call the Smart Manufacturing Innovation Platform. And I said at the outset, we don't have a product to sell. We absolutely don't have a product to sell. But what we do have is a number of contributing members, some of whom have products to sell and who have ponied up, have been willing to donate that technology to CESMII for the purposes of exploring how we solve these problems. So the stack looks like this, and it's not made up of any CESMII technology, but it's made up of member technology, people who kind of share this vision, agree that these are problems that we've made for ourselves and we need to solve, and have willingly donated their tech to the membership to explore how to solve the problems. Unlike the Purdue model, which still exists, we basically narrow the problems down to three places that align with the three problem spaces I just outlined. One is the ingestion of data. Two is the modeling of data, or better yet, ensuring that ingested data is modeled. And then the third is access to the context. Access to the data for sure, but with a protected context, with type definitions for objects, with those objects in relationship with each other so I can understand the context. And then surfacing that contextual data with all of those relationships intact to the third layer, which very broadly would be the application layer. The obvious missing piece is then, once I've got this good data out and I've understood the context and I've performed a useful prediction or made some useful analysis, I need to push a result back down to the OT layer, whether I'm one layer removed from it or all the way up the Purdue model and I'm 6 layers removed from it running somewhere else. At some point, I want to push a decision back, and we'll get to there. We have ways to do it now. The ways to do it now are akin to what we've been doing in the past. So we want the same disciplined approach to pushing results back down that we do to pulling the data back out. But at the moment, we're focused on helping humans make better decisions. And those decisions could be about machine efficiency. Those decisions could be making better energy decisions. But we can't enable good decisions without good data. So kind of incarnation one, or slice one, of the SMIP, Smart Manufacturing Innovation Platform, is to take existing software and build the pieces to knit it together for a particular expression of how we think we can solve the problem. But the second incarnation, or the second slice, is to take those learnings and to give them back to the industry as best practices or standards or evolved standards, and say anybody can implement these. It doesn't have to be the CESMII selected CESMII member pieces of the platform that you assemble to solve these problems. We're just recommending these best practices in your platform so that you don't paint yourself into a corner, and so that the end customer, the team that selects the application, is not stuck with a proprietary solution that solves a bunch of problems that'll need to be resolved next time they want to deploy a point of value. The main piece of glue that we use to stitch these layers together, the main evolving standard we're advocating for, is something that we call the Smart Manufacturing Profile. We call it profile because we have further use cases in mind for it than just information modeling, but other technologies call it similar things. Information model generically, template. The part one of the SM profile is a class definition. It is a structure for data that is repeatable. That could be because the physics of an operation are universally true as long as you're on planet Earth. It could be because even though there's a variety of machines and devices out there, they all derive from similar types of equipment, so all reliably have or should have some data within them. I'm watching time, and I could go on at length about profiles, but suffice it to say that the profile or the information model is the main thing that we're leaning into right now with the industry participants on having a way to declare a vendor agnostic information model on which to begin the analysis. So the more generic term information model comes from the OPC Foundation. We are partnered with them in a joint working group to make a UA node set. So part 5 of the UA spec is the only part we're picking sides on right now. You can still use your protocol of choice. But part 5, the information modeling portion of the specification, at this point has near global adoption. What it lacks is distributability, a centralized place to get information models that helps you avoid recreating them over and over again. And even though it's broadly accepted, it's not universally accepted. And because some of the criticisms are valid. So we're working with them to kind of address the concerns from the membership and from the other industry bodies that we're working with. So even though we are US focused, we're working with the Industry 4.0 team in Europe almost weekly. We're part of the Society of Manufacturing Engineers. We're closely partnered with the Industrial Internet Consortium. Mesa International provides some of our talent. And VDMA is kind of pioneering this idea of profiles, although their approach is maybe a little different than ours. And these are just some of our partners. We have over 100 members right now. But even with that firepower, a fair question is, how can we realistically impact an entire ecosystem? And the answer is, we need you. Like I said, kind of everyone on the bench at CESMII has been in this space for most of them even longer than me. And we've got the bruises, but we don't see everything. We certainly don't see all the ideas that are out there that potentially could be accelerated with investment. We don't hear all the challenges that you're facing as you build and deploy solutions. So we need participation. There's a number of different ways to participate that I'll put out there, but I want to end with this slide, which is 3 very specific calls to action. We have multiple funding waves where we, on behalf of the Department of Energy, want to invest in new innovation. Visit the website there. Hopefully this deck will be available, where you can find out about the waves as they come out, exactly what we're looking for in each wave, how to shape a proposal to increase your chances of success, to communicate your ideas well. If you have a good idea to make US manufacturing smarter or cleaner, we want to hear from you. We also want to build out these common platform capabilities, whether it's, like I said, the first slice, selecting some of the best of breed out there and figuring out the best ways to make them repeatable and make them work together. So potentially that's you, or translating those learnings to standards or to open specifications or to GitHub samples that can help people accelerate their own ideas without having to reinvent the wheel. Our organization is administered by the University of California. So these kinds of projects actually go through UCLA's supplier portal. If you go to that site and search for CESMII, we've got a couple in flight now. I'm on the hook to get probably another 20 of those going this year. So if you're a SI or a software developer in this space, I want to hear from you. And then finally, we're driven by our membership. The membership keeps us afloat and lets us keep giving out the money. The membership also helps us steer the conversations, get the right people at the table, and make better decisions with input from all sides of the industry. So if you don't want money from us for a project, but you do want to help influence the industry, consider membership. We would love to have you on board. That's it for me, Hans.
Awesome. Thank you. So folks, if you have any questions, either raise your hand or ask it in the questions. I had one. So I mentioned earlier, like we've been doing this series of meetups with Linux Foundation, LF Edge. In fact, Jason is in the audience. He's one of the board members of LF Edge. So the platform seems to fit really well into what what's going on under LF Edge, Eclipse Foundation with their IoT efforts. Are you planning on, or do you? Are you going to work with them? Do you want to work with them? Because that seems to be a good way to at least open things up, right? Because the standard is now in the code.
I saw the Linux Foundation. Maybe that was Jason. I saw his presentation on the edge layer.
Yes.
And I grabbed a screenshot. It was so close to our proposed architecture that, like, except for the colors, it looked like it could have been one of our slides. I would be super eager to engage. We have, like I said, there's two sides to the platform. There's existing ISV tech that we're trying to evolve towards common patterns, and then there's the common patterns. And I think we're so closely aligned on some of them that I'd love to have those conversations.
Well, here's Jason.
Yeah, let's chat.
Awesome. Yeah, and so Jason, that's also your comment in the chat. I'd also add that this anarchy was created on purpose because industrial providers wanted to lock users into their ecosystems. Yeah, 100%. And that behavior is still happening.
Yeah.
But, the manufacturers, at least the large ones, maybe the small ones don't know it's being foisted on them, but the large ones are catching on to this game and they're fed up with it. They don't want to be locked in.
Yeah, I mean, yeah, really good presentation. Obviously, you're very aware of the dynamics, and I've learned enough over the years to be dangerous. I come from the IT world, but I've certainly picked up some OT tricks over the years. It is easier to teach an OT person IT tricks than I think the other way around. But I've been in very uncomfortable conversations with IT folks saying, "Oh, hey, operations person, I can manage your PLCs from the cloud." They're like, "Get out!"
Yeah.
No. I'm just like want to crawl under a table. But it's interesting. So one comment I'll make too is that there was a piece that I did in a media inquiry around the Siemens Google partnership this last week, and there's a couple of interesting dynamics there. So all this stuff is spot on, and we're seeing this trend. Number one, with so much innovation happening, it used to be lock you in. There's so much innovation happening. There's not enough money in the world to fight off all the startups or the ankle biters. Either you change or you're going to get consumed.
Right.
We're seeing long-standing industrial players that are now stuck in this crossing the chasm, equation. And so, but what's interesting is the incumbents have the relationships in the channel, and they've been going to lunch with the production person for years and whatnot. But the challengers have all the new technology. But I can't tell you how many IoT platforms I've seen that talk about predictive maintenance, but those developers have never set foot in a factory floor.
Yeah.
It's you got to cross this chasm. But what's interesting too is Predix comes out 2014, and it's literally like I called time of death the moment I saw that, because like why are they trying to build IT data centers? That makes no sense.
No sense.
And then of course Bill Rue was like, LOBs, thou shalt use Predix, and they're all like, well, it's not ready yet, so I'm going to go out on my own. And then, of course, Siemens comes out and does MindSphere. And, better, they were using infrastructure from Azure and AWS, but still building the platform.
Right.
What we're seeing over these years is even the OT players are starting to increasingly, let me build on the cloud's PaaS platform, as a service, but I'll just add my domain knowledge on top. And that's kind of where things are headed. But there's still infighting. The Google announcement with Siemens last week was literally these. I mean, this is all public information. I'm not sharing anything that's not well known. It's the CESMII business, which is their edge effort from a hardware perspective. And by partnering with Google, and there's some links to, they bought a company called Pixium a couple years ago, and they had a partnership with Google, again, all public information. They've basically created an edge to cloud offer that now competes with Siemens' own MindSphere effort. That's kind of what's happening, so there's still a lot of confusion. There's still a lot of I must own the middle,
right?
Because that's how I own the customer. But the reality is exactly what you guys are doing is like, if you don't own the middle, you can focus on value versus undifferentiated heavy lifting. And that's exactly what we're trying to do in Linux Foundation, with LF Edge, very, very aligned, like you said. So we'd love to talk about how there might be a partnership, but I'll give myself the hook. But yeah, it's just interesting, the dynamics happening.
Yeah, and one of the things that I think we came to the realization on is the middle isn't as important as the edges, and edge small e. The boundary between the components. Eventually, the components are going to get commoditized. Cloud is cloud. That there are a variety of kind of unique things about each cloud platform, some of which are exciting to exploit, but ultimately they're renting infrastructure. The boundaries between the point of value, the application that consumes data from that infrastructure, and the infrastructure itself, if that boundary is an open standard, then customers have the freedom to say, I'm getting behind Google, or I'm getting behind Microsoft, or I'm rolling my own, and best of luck to each of them. We'll see how all that shakes out. But the point of value doesn't go away if you find you've made the wrong decision, or if Google loses interest in manufacturing again this year and decides they're not going to invest in it anymore. Your application can continue working if there is an open API or a common standard that it depends on, rather than a proprietary interface that it depends on.
And one of the reasons why that's exactly why it's so important to start with an open edge, because if you go straight to a cloud, and the clouds are doing great things, there's nothing against the clouds, but before you know it, you're locked in and you've got every dependency down to the devices at the edge, and then you get the bill. When you realize that the temperature example you use for the data lake monster is like, why did I keep saying, hey, it's 72, but by the way, did I mention it's 72? Oh, hey, it's 72.
Yeah.
You want to filter all that at the edge, but vibration especially, or computer vision. But so by decoupling yourself the moment data is created, and this is again a big point of, I think, the open architecture you're talking about, what we're doing in LF Edge, under your terms, all permutations from the edge to the cloud work. And if you want to go to one cloud, great. But last I checked, manufacturing environment is like super, super complex with lots of service providers and supply chain stuff. And the odds of everyone going to one cloud is pretty much zero. So again, it's really important to start with that open edge. I don't know, Hans, if we, I don't want to, it might be kind of cool to start talking about the trust stuff in one of these sessions, the trust stuff, because that's the next thing. It's, this is the blocking and tackling, but long-term it's about interconnected ecosystems through trusted operations. And no, it's not just blockchain. But anyway, it's right on the money. I was just, really good presentation. So
thanks.
Thank you. Yeah, and I think just on the open source side, so I've grown up on the tech side, right, on the IP side, and worked for the proprietary vendors who eventually got disrupted by essentially companies that were enabled by open source, right? And today, even 10 years ago, right, if you're an individual developer, so to me the analogy would be as a small manufacturer. If you're an individual developer, you need a bit of money for infrastructure, right? So you could build your application, run it, and whatever.
Oh, you're muted.
Funny, I'm like,
Yeah, there we go.
audio. That was weird.
Yeah. So you know, the one of the things that it really did was it actually enabled a individual developer, right? It enabled a lot more innovation, right? The open source did, because you got building blocks. You didn't depend on anything that was proprietary, right? And I think it's the same here, right? If we want to enable the small manufacturers, we have to look at the open source bits as an enabling component for that, right? Because, you know, I go to a lot of trade shows here in Washington, Oregon, manufacturers. Very rarely see any of the big vendors here, right? Exactly what you said. It's never, right? I don't think I've ever seen a big vendor show up at any of the manufacturing trade shows where it's mostly small manufacturers. So, no, this is, I hope you guys get together and work something out.
Yeah, it might be another discussion, but my relationship with open source is maybe a little different from those that sit in the Linux Foundation. I'm not opposed to vendors having software. Yeah. What I'm opposed to is the ecosystem lock. Not even the ecosystem lock, the rudimentary, crude, and destructive attempts at ecosystem lock. Like, this isn't Apple here, where they have a full, rich ecosystem, and if you choose to be in that ecosystem, you'll probably be pretty happy. These are vendors with incomplete parts of an ecosystem, trying to make a land grab across all of it, that often goes outside of their core strength. So by all means, sell proprietary software within your core strength. Yes. But at the boundary of that, you need to have an open spec or open standard interface so that your customers aren't hamstrung by your relative immaturity in, you know, the next frontier, which is.
Yeah, I mean, well, one thing I'll say, so totally agree. Like, in the way we set stuff up in Linux Foundation, this goes beyond LF Edge, is open source is a modern way to drive standards, and it's actually more about the APIs driven through that code collaboration than it is about the code. You know, like, I helped get EdgeX started, for example. Like, you know, that project that, I mean, I think it's you know, kind of taken off, whatever. It's cool, and then we continue to work in LF Edge. EdgeX, when we architected it 5 years ago within Dell, small group, before putting it into Linux Foundation, we very purposely did not do analytics stuff. We very purposely did not do some of the orchestration, you know, benefits, because that's where the money's made. You know, you got to democratize the South to monetize the North, as I would say. And you make your money on the IDIs: security, manageability, usability, scalability. You don't make your money reinventing the middle over and over and over again.
Yeah, right. And that part should be commoditized. Yeah.
Yeah. So that's the approach we took. I think it's kind of par for the course for most of the projects. It's like just enough to bring together an ecosystem, just like Android did for mobile. I mean, I'm spoken to someone with a Mac, and I mean, nothing wrong with Apple, but there's a reason why Android has 80% of the global market, because open drives a network effect.
Yeah.
But anyway, so yeah, I think a very common misconception with open source is that means I have to give away all my IP and I have no differentiation. It's completely opposite. It means stop undifferentiated heavy lifting and get more IP. You know?
Yeah. The hard building blocks, build them as a community, right?
Yeah.
Things that everyone needs. Yep. Cool. Anything else, Jason? I have a couple of questions.
You keep me going, I'll just keep talking. So I'll just.
All right. Well, there'll be time if you're around. We'll be in the.
Yeah, I'll jump over. I got like 15 minutes, but yeah.
Okay. Cool.
I appreciate it. So I'll drop off for now.
All right. Next. So Millen is next. So there's a question here. Are you ensuring that your grant winners follow the CESMII profile standards? I worry the vendor members may be tempted to subtly lock the customers in. Yeah, that's a good question.
Yeah, perfect question. I think early in the Institute and in some of our funding, we didn't have, we had the carrot, which was here's the funding, but not the stick. You have to embrace the our approach. We definitely have both the carrot and the stick now, and probably for the past 2 years. All the projects are expected to produce a profile. Per the previous conversation, they don't necessarily have to give that profile away, but it has to be an open spec information model that is reusable. It can't be a proprietary solutions template.
Awesome. Fantastic.
Or you can't have our...
You can't play.
Yeah.
Hey, Millen.
Hi, guys. Can you hear me okay?
Yep.
Yeah.
Go ahead.
So, very interesting talk. I actually managed to jump in right when you were talking about the data lake. And I have to just share a little bit of experience. I think it's going to be useful for everybody just kind of from the floor. My background, I came in from mechanic on the floor. So I actually was the guy who was implementing this kind of stuff. So I think it's very important what you said to work with the people on the floor. But just to kind of give a quick story, at Boeing, we implemented a tracking system to track where production equipment is all over the floor, and they used it to figure out utilization, how many hours you work in a day on a scissor lift and all that. But because they didn't go to the floor to find out when how the asset was used, they only looked at when the scissor lift was moved. And as everybody knows, the scissor lift works when it goes up and down, not when it moves from point to point. So because they didn't include the data scientist in this, they had a 95% of downtime. And then they took the data scientist who looked at production, asked them how they use it. Oh, you actually go up and down. You don't move stuff with it. They looked at the data again. It turns out they had like 97% utilization instead of 95% downtime. So it's very important, even if you have all this technology, to go back and see how they use it.
So
this was, yeah.
I hope you don't mind if I borrow
that. Oh, no. By all means, I've seen some things where people assume that things work in one way, and they think if you just bring in an IoT solution or technology can do it for you, you can just say, well, it's taken care of. I don't have to do anything. Well, you still have to set it up right to begin with. Like you said, just because it's saying it's 72, it's 72, it's 72 all the time. Is that a good thing, a bad thing? Or?
Right. Yeah. So that we call that the context. And yeah, just the notion that I just moved this data and figure it out later.
Yeah. Oh, awesome example, Millen. So Millen's at Boeing, right? So he usually has the real world stories while everyone else geeks out. He's like, let me bring you down to earth. So awesome. Anything else, Millen?
No, I just wanted to share that because I think it's very
that was actually very appropriate.
That gets missed a lot. You have a solution, but you don't know where it fits instead of going to find what the problem is and then figuring out the solution. As I keep telling Hans every time we chat offline, it's like the engineers say, I have a hammer. You should use it on your nails. Well, we don't use nails. We use screws. Well, you should switch to nails because we are selling you a hammer. Well, nails don't work for us. Well, either way, get a hammer and use nails. This is what we're offering.
Yeah. All right. Thank you.
Thanks.
It's a good one.
Yeah, you have a use case that you can use. Okay, looks like that was it for the questions. Yep. Cool. Okay. Jonathan, thank you very much. This was really good. I'm glad you connected with Jason. I'm glad Jason was able to join because this was one of my questions. Was why not involve the some of the foundations? Because as soon as you put up your platform, I'm thinking, wait, that looks exactly like what we've seen before with the LF Edge, right? So I hope you guys connect. Thank you again. If there's anyone else, actually, even from CESMII, who you think would share a different context, because I know there's a lot of deep experience in CESMII, it'd be great. Would love to host them. Otherwise, thanks, and you're welcome anytime. I don't know if you have time to hang out for a little bit in the lounge.
Yeah, thanks so much for having me. I can hang out for 11 minutes. So
okay. Wait, we just have one person who just asked a question, so I am going to just give them the stage, and then we're going to finish.
Okay.
Hey, Roshan.
Yeah, hello.
All right. Go for it.
Yeah, so sorry if I am out of context because I just hopped into the room. And so my question is that I'm going to be really brief. I'm a researcher at OSU, Oregon State University, and we have developed a small computer vision application that monitors the shop floor and tells you exactly like our previous friend just said, when the modules come in and they leave, and computes the cycle time on the shop floor using the surveillance video cameras. And I was wondering if like you can talk in terms of how we can, if these things can be used, or there's a promise for this kind of application in the factory for automation of monitoring.
Yeah, I think two parts to that. 100% there is a use case for that. I think if it's built, I think you should look for an opportunity for an innovation project where you get with the manufacturer and deploy it. If you're still researching, we have a type of funding for that as well. The link that I put, we do have some upcoming waves. I can't pre-announce anything. But we do have some upcoming funding waves, and I think it's reasonable to say we'd be very interested to engage with you, hear more about what you're doing, and help you find the right avenue to accelerate it.
So we have developed it. For some part, it's a prototype. You can see it. So where's the link? How can I connect with you after this meeting?
Yeah, so I'll grab the deck of Jonathan, and I'll post it up somewhere, and for sure I'll put it up on the Discord server, and we'll share it with you. But yeah, good question. All right, so with that, I'm going to switch it so people have time to ask individual questions and at least network. Again, thank you, Jonathan, and for however many minutes you can hang out, that'd be awesome.